Thank you. Thanks for the introduction. Hi, good evening, everyone. Today, I know the conference is going well, and I guess it's going good for everyone. Today, I'm going to talk about Docker networking and orchestration, which is provided by IBM SDN-VE and SaltStack. So, mostly, I'm going to cover in three parts. The first thing is about SDN-VE. I'm going to give you an overview of SDN-VE, what it's capable of. And the second part, I'm going to cover on the usage and how's the use cases, typical use cases where it's been used. And I'm going to hand over to CR for talking about the Salt. And the final part of the session, I wanted to use the demo, where we wanted to demonstrate what we have done with the Salt and IBM SDN-VE here. SDN-VE is an overlay-based solution where it can provide networking. It's a heterogeneous thing where we can network different type of applications running on bare metal. It can be a container host or a hypervisor host. Mostly it can create virtual networks, it can create tenants, and you can provide networking. So Docker networking can be done with many ways, but SDN-VE is more robust, and we have it's a product that's GA'd actually. And we have the virtual networks created, thereby separating the tenants so the traffic can be isolated. Also, it's a multi-tenant, very secure. We can show you the demo where I think CR will be able to show that we can rent out servers from SoftLayer, install Docker, and then create containers in it with images there, and then SDN-VE providing the networking. So if you see from this in this picture, whatever I stated about the virtual network is already depicted. And also, SDN-VE can work with the legacy devices like LDAP servers and things like that. Like we have a VLAN gateway where it can be interfacing with. So it's just a mapping of the virtual network into the physical network, which is shown here. And also, if you wanted to go outside the network of the SDN-VE to the external world, we have a gateway here, where it's going to translate the traffic from the SDN-VE network to the outer network. So we have all strong APIs here. Mostly these APIs are exposed northbound. If you want to create a tenant, you can use the APIs to create a tenant, a virtual network, a subnets, which is pretty much straightforward. It can be orchestrated from an external entity. So that's how we started engaging with Salt, and we were able to demonstrate that today. Okay, next slide. So mostly whatever I covered is mentioned here. Like there's no change in the existing physical network needed. It's more API driven. It's a robust control plane with high availability, and it has the automatic load distribution. So if you see in this slide, like the existing network, which we have the orange ones and the yellow VMs there. So we can create networks which can talk only to the orange network and the yellow ones to the yellow network. So without changing any kind of the underlay, we can create the virtual networks, and it can be communicating between them. So there's a isolation also, which is a key thing, because we don't want to mix up traffic between two tenants. So this is what we can create about 16 million virtual networks rather than 4K traditional VLAN, which has the limitation here. We can reuse the IP address and MAC addresses for across the different virtual networks. So this is one of the use cases which I was talking about, is that bring your own IP, where you can see that the customer network 1 and customer network 2 can bring in the same kind of IP address, and still can be used without changing anything in the underlay. So this is one of the use cases which I think will be very useful with SDN-VE. Next slide. And also, interesting point is that we can add network services, like for example, with service chaining, we can do firewall, load balancing, IDS, IPS. We can add as waypoint servers to this, so which is very useful if you wanted to deploy in a private or a public cloud. In fact, our IBM offering on the Zenith and Quasar public and private clouds are using SDN-VE. So this is a typical use case of a hybrid cloud where we are extending the network, the 5.5.x network over the internet to the soft layer. And we're again using the SoftLayer services. So pretty much I think this slide demonstrates that you can have a hybrid cloud deployment using SDN-VE, providing the networking. So it can be containers, it can be VMs, or any kind of bare metal servers there. So this slide is about the foundational services, what we have. So again, where you can see from the customer network being extended into the soft layer, where the customer network has 40.1 network, and we have a VPN tunnel, and it goes through the VPN tunnel, and then we have service chaining in place where the firewall to inspect the packets and analyze, and then give the access privileges, and then you have a load balancer to load balance the application which is running in the server 1 and server 2. So all these are part of native IBM appliances, which is based on OpenStack. We have service chained it with SDN-VE, and everything running in Docker containers also is available. So mostly, as I mentioned, we can have access with OpenStack, and the next is about the REST APIs, and we have also some kind of prototype on the appliance load auto-scaling itself. You've heard about the auto-scaling on the compute, but even the load balancer can scale up and down based on the compute loads, which we have a prototype and a POC for that. So now I want to give the chance to CR. You can talk about CR, the Salt, and then we can move on for the demo.
Okay. All right. So anybody use SaltCloud here? Okay. Well, you don't count. You're in the back. So SaltCloud is a piece of Salt. It's part of the Salt system. And we use SaltCloud to spin virtual machines up and down with automatic Salt key acceptance, which is really handy. And that's kind of really how SaltCloud was born. We kind of got tired of starting up a machine in the cloud and then going to have to accept the key. And as SaltCloud grew, it became really this fantastic Swiss Army knife tool for starting up and managing machines in the cloud. We have a significant amount of support for SoftLayer inside of SaltCloud now. And one of the things that I worked on that we're going to show in just a minute is extending that to support requesting and mounting iSCSI storage for machines that are running on SoftLayer. And also, we even have some APIs that go directly into SaltCloud, so you don't necessarily have to use the CLI. You can use the REST API, which we have through what's called Net API now. We used to call it Salt API. If you look up Salt API in the docs, you're not going to find it. It's all under Net API now. So you can actually script that or perform a number of orchestration scenarios with SaltCloud. SaltCloud supports multiple providers. And it's actually pretty easy to reset things so that you can kind of pick up your infrastructure and move it to a different cloud. And obviously, you're going to have to set up some provider configs for that. There are also defaults available for profiles. And just kind of an example, here's one for SoftLayer. Really simple to set up. We just specify which master we're going to use, give it a username, and the provider is called SoftLayer. SoftLayer requires a password and an API key, and then you could talk to SoftLayer through SaltCloud. And then for every kind of machine that you want to spin up, you'll use a profile configuration. And here's an example for that. This is actually the profile that we're using for the demo. We call it Docker host because we're spinning up 2 minions in SoftLayer, and both of them will host some Docker containers. They're CentOS 6 machines, 1 CPU, a gig of RAM, 25 gigs of storage, and it's local storage. And it's located in the San Jose data center. SoftLayer has a number of locations. They've got data centers all over the place. So just to move data centers is just a matter of changing the location option in your profile file, or you can actually push that default even up to the provider if you need to. Just kind of a quick example of what SaltCloud looks like. These are some of the commands that you can use to get information about VMs. Let me make that a little bigger. For instance, SaltCloud-Q, and there we go. So these are actually the VMs that I have running on SoftLayer right now. And then if you can also get some information back about stuff that's available. List images, SoftLayer, I think. So these are all the images that are available via SoftLayer, a whole bunch of them. Not as many as Amazon. Amazon actually will list all the AMIs that are available, and the data stream you get back is like 600 megabytes or something. It's huge. So did you want to say anything else before I go to the regular demo?
Yeah.
Okay.
So the demo is mostly going to cover, like, we're going to order a couple of servers in the soft layer, and we're going to install the Dockers and get images, and then provide SDN-VE to provide the connectivity. And also we are going to use some soft layer services like iSCSI.
Okay. All right, so let me just draw you a little map. So what we're going to do is we have a Salt master running over here. And the Salt master is going to spin up one minion, which we called M1 in most of the tests, but right now it has a different name. This one is actually NCS Demo. And then over here we have a second minion, which on the slides is called M2, but in the demo it's SS Demo. And so those are going to be spun up through SaltCloud, and then when you spin those up, the bootstrap, if you've worked with Salt, you know we have this bootstrap process where we install the minion on actually install the Salt minion on the machine that we're controlling. So that stuff has already been done. So after you spin, SaltCloud takes care of all that for you. Then what we're going to do is we're going to create a Docker container in here that has a load balancer in it. And we're going to create 3 Docker containers in this one. And these are all going to have Nginx on them. Well, what's interesting about this, you've probably seen this kind of demo before. It's kind of our stock demo for some of our orchestration stuff, because it's really kind of neat. You can, with just a few lines of YAML, you can set this up and just say, salt state.high-state, and boom, you've got this small cluster running. What's interesting about this, though, is that normally what you do is, the load balancer would export these ports, let's just say 80 and 443, over the general internet or over a private network that's shared, with these Nginx containers, and these would be exported on, probably 8000 and 8001, 8002, and then you'd point the load balancer, at these ports. And this would all just happen over the private network that's present in most clouds. Linode's got it, SoftLayer's got it. It's just a 10 dot network that's available to all your machines. Well, what we did differently here is we used SDN-VE to give the load balancer, and I'm not going to get the addresses right. I think load balancer we did 11, and then the containers we did 12. So this is a 12 network, 11, 0, 0, 24, 12, 0, 0, 0, 24. And then in the middle, I should draw a box here. This is SDN-VE. In the middle, we created what SDN-VE calls a middle box. And the middle box has 2 endpoints, 13.0 and 14.0. And so essentially, all of the traffic between these containers doesn't go over the private network that the cloud provider gives you. It goes through SDN-VE. And all that's configured by an agent called the Dove agent. So basically, I'll show you this in a minute. And it's all done through a REST API. So I wrote execution modules that would call that REST API. And you just give it some endpoints and say, OK, I want this middle box. I want the network to be configured like this. I need these 4 subnets. And it calls out the SDN-VE and returns you a bunch of what's called VNIDs, virtual network IDs. And I think you'll see an example of that in just a second. And then you just connect all that stuff together. And one of the neat things about this is, like what Siva was saying, you can just kind of pick this network up and move it somewhere else. Or you can create a second tenant that's a clone of this network. And so you're not running around reconfiguring DHCP servers and doing all the other stuff that network guys like to do. It's much easier to handle a large infrastructure. And like Siva said, it's very secure. That traffic is not available to be sniffed. SDN-VE handles all that stuff for you. So this is kind of a quick overview, and then we had a joke about angering the demo gods a couple weeks ago. I don't know if I did that today. We'll see if that happens. All right, is that big enough? Can you guys see that? Okay. All right. So we've got these two machines, and I'll just say salt-l, ssdemo, ncsdemo, test.ping. Okay, that's the first test. And they're both there. Yay, okay. So the demo guys are not angry at me yet. Let me show you. Okay. Okay. So Salt has this concept of what we call the top.sls file, and it's kind of the default configuration file for setting up your infrastructure. And the top file is what's consulted when you run what's called a high state. So, and high state is just kind of a fancy name for this is kind of the default state that I want all my machines to be in. So if you scroll down a little bit here, there we go. These two machines, we're going to do three things to each of them. We're going to run this SLS file called Docker host. We're going to run this SLS file called dev package, and then we're going to run another SLS file called salt restart, and you're all very smart. I'm sure you can figure out what that means. In general, you don't need to restart your minions. They do pretty well on their own, but in this case, we install some Python packages, and the salt minion doesn't see them till it restarts. So that's why that's there. So let me show you what the first one looks like. Docker host. Oh yeah, that's wrapping all over the place. Okay. So the first thing we do is we're just going to run package up to date to make sure that all the packages are up to date. We're going to install these things: Docker IO, Python pip, git, parted, some Linux utilities, and at. We're going to install some Docker Python bindings, upgrade pip. We're going to upgrade requests, which is a Python library for doing REST calls. We're going to refresh all the modules on the minions. We're going to make sure that the background Docker daemon is running. And then I'm just going to default root's password on these machines so that I can remember what it is, because otherwise SoftLayer will give me one and I won't ever remember what it is. So, all right, so that's Docker host. And then dev package. Dev package has a few dependencies: iotop, libvirt, and the Python libvirt bindings. It also needs a version of IP route that's not it's not in CentOS 6, or at least not in the images that we were using. So we needed to install that, and we need to kind of do it specially because it replaces a bunch of files. So then we're going to take this file, this RPM package called dev agent, because it's not in any of the regular repositories, and Salt makes it easy for you to install that stuff. You just do a file.managed, and it brings that file down to the minion, and it just drops it in temp. And then we're going to run an install on that one, RPM-I. Since Salt is an orchestration system, it knows a lot about your environment, and so we are going to manage the dev.xml file. That's the file that configures the dev agent. And the dev agent is what basically connects the minions to SDN-VE to be able to tell it, okay, I want this network here, or export me this network over here. So we're going to template that file and then send out the templated versions to the minions. And then we're going to restart the dev daemon, because we need to do that. And then we also need libvirt running. So we'll just make sure that that's running. And actually, libvirt gets restarted. This is a watch directive. So anytime dev.xml changes through Salt, then these daemons will get restarted. And then just for the heck of it, Salt restart. It's kind of hard to restart Salt with Salt because you send Salt the restart command, then the daemon dies off and doesn't send the response back. So, and it recovers okay from that, but it's a little less traumatic if you do it this way, where we just schedule the service.restart 1 minute from now. So at least the communication gets over the event bus, and the minion can respond and says, oh, I have that job, I'll do that, and then a minute later it dies off and then resurrects itself. So that's what that's about. Now I'm not actually going to run a high state because it takes a long time. And so we just did it in advance, and I didn't want you guys just to sit around and wait for that to get done. So now let's get over to the orchestration part. So now we've got these, now we have the minions set up themselves. And now let me show you how the orchestration works. So in this orchestrate directory, I wrote this orchestrate file called sdn-demo.sls, and it looks kind of the same. This is a real feature of Salt. A lot of what you find in Salt is just configured with plain YAML. It's just text. It's not hard to understand. We do support writing states and stuff in Python, or we have a DSL, which some people like to use. There's nothing wrong with that. It works just fine. But a lot of it's just plain text, so that makes it easy to deal with. So this is an orchestrate file. It basically says, I need to target these machines, and I need these things to happen to them. So in the original version of the demo, we were using these machines called IBM M2 and IBM M1. I kind of mentioned that over there. And we just changed the machine names. And I ran this orchestrate earlier because this also takes a while, and I didn't want you to sit around waiting. So the first thing we're going to do is we're going to request some iSCSI storage from SoftLayer. And that happens in this SLS file. And if I pop up here, I'm in the wrong terminal window. There we go. Okay, so we have an execution module that one of my coworkers wrote, Colton Myers. He's not here, I can't tease him. We joke about Colton because he actually wrote a book about Salt, so we say Colton wrote the book. So we order and mount storage. That basically calls out to the SoftLayer REST API and says, give me a 20 gig block of storage. And the API comes back and says, yes, you can have that, and we will charge you for it. So then we take that storage, and it gets an IQN like all iSCSI stuff does, and the execution module takes that IQN and does the necessary magic to actually attach it to the host. And then we use parted to format it, or to partition it, and then format it and mount it. And then we do this file recurse right here, which is Salt's way of saying, I need to take a bunch of files and I need to move them over here. So out of this directory called SoftLayer_iSCSI, that's where we put all that content that's on the Salt file server in the iSCSI content directory. And that also has a requisite, this state will not run unless order and mount storage is successful. So that's the first part of that, and the rest of this won't take long, I promise. Okay, so then we're going to deploy Docker containers, and I'm actually going to run through that with you in just a second. And then we'll deploy the load balancer, and then we'll actually set up the network. That's the part that calls out to SDN-VE and does what we need it to do. And then there's some interface work that needs to happen where we attach those interfaces to the SDN-VE network. And then we make sure HA proxy is properly configured. And then we go in, and this is kind of a really nice feature of Salt where you can actually loop through a bunch of information to do something. And so we're starting 3 Docker containers, and I stored that information in Pillar. So we're just going to loop through that information in Pillar and start those 3 Docker containers all together. Okay, so that's that. And so first we'll start by running demo. I'm going to run a single state file, state.sls, which is what the orchestrate does for you, and called IBM M1 config. Oh, and I'm running it on the wrong machine. Okay, there we go. Okay, so what happened? All right, so we have a directory called HA proxy override that actually contains the HA proxy configuration. And then, so we're gonna manage that particular directory. Then I already did this earlier, that's why that was so quick. We pull the HA proxy Docker image down And so it tells me, oh, look, it's already pulled, so I don't need to do that again. And then we actually have a state for firing up Docker containers. And normally it works pretty well, but you can also do it with just command.run, and so that's what I did here. And we're just running that container, and we're going to forward these ports to the right place, and SDN-VE will pick those up. So that's the first one. And now we're going to do it for the Nginx containers. This one takes, oh yeah, I was going to say it takes a little longer, but it's already done. Same kind of thing happened here. Okay, so we're templating the Nginx configuration. This is the directory that actually contains the mounted SoftLayer iSCSI stuff, and it's in the correct state because I did that earlier, since it actually takes a while to format that iSCSI partition. And then here we're asking for the Nginx Docker container, and that was already pulled. And now we're actually starting those up. And we're doing it 3 times, but I only wrote it once. I just used the loop to go through all 3 of them. And it's forwarding the ports where they need to go and all that kind of stuff. Okay. Now we need to bring SDN-VE into the picture. So I'm going to run the individual execution module. Rather than doing it through Orchestrate, I'm just going to run it by hand. And we called that, refresh my memory, master, let's see. Oh, yeah, I know, I need the interfaces. First, let me get the interfaces so I know where to tell SDN-VE to connect stuff to. NCS demo, network.interface. And we want ETH0 on both of those. Okay. And, oops. No, we're running this on the master. And it's called, it's driving me nuts. Oh, yeah. Yeah, I called it dove-rest. And the function inside of dove-rest is called chain. And we need to show you, I think I called it dove IP, oops. And that would be this machine. Dove NG, yeah. All right. Okay, so right now what it's doing is actually talking to the SDN-VE controller and saying, set up these networks for me. And there we go. All right, and in the process, we created a new tenant. Now here's the tenant prefix name, Salt788. And so in a minute, I'm going to show you in the GUI where that, if actually I don't have to wait, let me just go over there right now. I'm sorry, that's kind of small. I can't make it any bigger. That's the wonder of VNC, Salt. So let's look for Salt788. There's that tenant. And we'll look under logical groups. Here's the tenant. And here are the subnets. Okay, so we've got one for the client, one for the server, and one for the middle box, which we called LB for the load balancer. And these are all GUIDs that SDN-VE creates so you can tell those apart. And then there's subnets for each one of those also. So we've got, did I say? Yeah, I did say 11. So we've got 11. The client subnet's 11. Yeah, I think I flipped that, but I don't know, this is what matters in here. 11, 12, 13, and 14 are all right there. And then if you look over here, we also created, in addition to the middle box, we created a service chain and a policy for routing that traffic. So you can find that in our connectivity service. If you drill in here, this always takes a second. Yeah, there we go. So here's the middle box, and the associated service chain is just a load balancer. That's what that icon means. And then under policies, this all got created through the REST API, so you can actually see what's happening to the traffic from the client subnet group to load balancer to the server subnet group, and then here's the reverse. Same thing, it's just reversed. So that all happened through the execution module calling the REST API. All right. So now everything should be set up. Let's see, is that the right IP? Yes, look at that. Okay. Thank you. Yeah, that's so if I keep hitting this, yeah, you'll see I'm talking to HA proxy, but it's giving me content back from different Nginx containers. And then I should have exported the port so you could see. I didn't export it. Naveen might show you, where you can actually look at the stats that HA proxy provides you. You can see where the traffic's going to the right thing. So, and then really quick, let me just look over here and see. Let's see. Yeah, there we go. Okay, so I should have shown you that these weren't there before. But so this all works. The way this works is the Dove agent creates bridges for this traffic. And so that's what these are. And each one of these numbers refers to a virtual network ID, which I talked about before. And that's how you can track back. So you can look at the machine and say, oh, here's the VNID. Where do I find that in SDN-VE? And that helps you keep track of which bridge is talking to which network inside the software-defined network. So, and this is just on the load balancer. And there are bridges over on the machine that's running the Nginx containers. But so anyway, do you want to take over? Okay, cool.
Yeah, so
Find your
just go to that. You're showing
the VNC.
Yeah, VNC. No. I just thought we can just to quickly show the stats.
Oh yeah, your stats. I don't remember your IP though.
Yeah, I think what you're doing, we can go back to that slide.
Okay.
Just to HA proxy. Just doing the Nginx.
So the PowerPoint or?
One you were just showing this one, right? IP address. It was doing load balancing. Just
oh.
Show the stats.
Yeah, I'm not sure that's there.
If it's not there, I can show you.
Yeah,
Okay.
I did not export that port, I don't think. Oops. Yeah, that was my fault.
That's okay. Yeah. So I guess we're pretty much done. So you can go back to the slide that has actually talked about what demo we did, the steps.
Can you go to the last slide where we can summarize it?
Sure.
Yeah, that we can have questions.
The previous slide. Yeah. So basically, we just saw what CR was demonstrating, right? We had two machines, M1 and M2, and one has LB in a container, and the second one had the Nginx web servers in containers, and SDN-VE, which is running outside of these two machines, and which has its own components, which are infrastructure VMs, which are running there, which is the controller part, and which is connecting between the load balancer and the web servers. We ordered two servers because we pre-ordered, because it's going to take some time to get it, so we pre-ordered that, and we're configuring on the Dockers everything he showed you. So pretty much we can do, even we showed you the service chaining. It doesn't have the firewall here, but we can insert anything, any firewall or IPS or IDS as part of the service chaining. We just showed you the service chaining with load balancer and the web servers. So the web side to the backend side. So we tried to show you that. So pretty much we can do service chaining, and SDN-VE, and with Salt we were able to do it all with REST APIs, and it's very it's exposing thing, and we can manage it with OpenStack with REST APIs. So pretty much this is what we wanted to show you guys, and if you have any questions, we'll be happy to answer them.
What kind of distance can you have between the networks? Can you span subnets, regions?
there's no any limit like that. You can span it across.
Yeah, that's actually what this slide shows here.
You can go across the internet.
How do you handle redundancy? Because to me, when I see this, you're introducing another single point of failure. So how do you make that happen?
Yeah, redundancy in where?
So I assume that the SDN-VE is a process running somewhere. It's some software.
Okay, let me explain a little bit more on SDN-VE. SDN-VE has components called DMC, which is called the management console, which is not a single console, which is a cluster actually. And also it's called a DCS, connectivity service. It's also a cluster. So it is highly redundant there. So even one goes down, there is a monitoring process which takes care of the bringing up the other one. And it's active. So in that way, that it's not a single point of the failure.
I just want to quickly show Shiva.
Yeah, you can show the problem. Those are the infrastructure pieces which are running as VMs, which are not containerized, but those are all VMs. It's not a single point of failure.
So this is quickly, I just want to show you, this is some of the infrastructure components. We have a controller which is redundant. You can have multiple controllers you can run. And we have a couple of other components. You can run like more than one. Here we are running only one instance of DCS and stuff like that. You can run more instances to get your redundancy. And
You can run intra-site.
So this is the infrastructure. We didn't get a chance to show you. This is what our SDN controller is. The GUI which you saw that it is actually talking to this SDN-VE controller. This is actually installed on a bare metal Linux machine, and all these are VMs actually, infrastructure VMs.
So is there any integration with OpenFlow controllers or any plans to add that protocol?
The OpenFlow, do you mean the Pinnacles one? Pinnacles OpenFlow controller?
I'm sorry?
Did you mean the Pinnacles OpenFlow controller?
No, I meant like what's used by like Open vSwitch, like the open implementation.
Yes, actually, there's no limitation as such, but it needs some kind of testing effort. So because we expose everything on REST, so it can be always taken to any kind of things. So this SDN-VE is available in both like VMware version and KVM version. So typically any Linux version is fine, but this is running Red Hat Enterprise Linux here.
So how much does it cost?
That's a good question, but I can get you to the right folks there. Right now it's been provided as a service, and our team works with other folks in the cloud. We are part of cloud networking team. So we have the single tenant and multi-tenant, like public and private clouds from IBM. So we provide service to them. So I can get you in contact if you want to know about the pricing.
Could we conceivably do the same thing? Nothing against SDN-VE, but could we do sort of the same thing with the overlay networks and connecting the bridges through Salt with just a switch?
You can do SDN-VE, or it can be OVS. OVS again, you need to create networks. With Docker networking, you may be using V, or it could be Flannel, whatever. You need to have connectivity for it. But OVS, you need to have a GRA tunnel established between the endpoints, right? So
right. Yeah.
If you are going over the internet, like your previous diagram, is it? I guess you had VPN server there, so probably. But can you force encryption on this layer?
It is encrypted. The VPN is I think if I remember correct, it is based on a snort, and it's encrypted with IPsec VPN here, which goes across the internet, and then we terminate. It can be any client. The server can be anything.
What about the performance impact? What kind of overhead is there in sending this through all these things multiple times?
Yeah, I mean, the performance we have depends upon the topology and the use case actually. We will be happy to share you the performance numbers what we have run, but it's very specific to a topology, because we cannot generalize it like it's like maybe in 10 gig, like probably 4 to 5 gig maybe.
Any other questions? Okay, so Naveen and Siva will be here the rest of the day, and then they're going to go back to California. I will be here the rest of the conference, and I'd be happy to talk to anybody who wants to discuss the demo or know a little bit more about what we did underneath. As far as the code is concerned, we're kind of going back and forth on that. We're kind of in some high-level discussions about what we're going to do with that code. I know some folks at IBM would like us to open source it, so that's definitely a possibility. But that's something we can talk about.
Interestingly, this SDN-VE is built on OpenDAO. If people are aware of OpenDAO, so it was built over that OpenDAO, and it will be coming back to the open source community.
Okay, I guess we're good. Please leave us some feedback in the mobile application if you have a chance. We'd appreciate that. It helps us pick our sessions for next year as well.
Right. Thank you very much.